All right, so to highlight a few more things we're proud of here at Wilkes, we were awarded a $3 million grant from Pennsylvania in order to improve on the following labs that are cutting edge technology: additive manufacturing, the 3D printing lab, nanotechnology, and bioengineering. So here I have just a short news clip showcasing.
Learning in a 21st century environment, a local university has a new state-of-the-art engineering department for students. Eyewitness News reporter Cody Butler takes us inside.
A crowd of more than 100 people came out to Wilkes University Friday to dedicate the new Mark Engineering Center inside the Stark Learning Center.
I went away for the summer and I came back and I was just totally impressed with how modern, this new wing of Stark looks.
Associate Professor of Mechanical Engineering Ed Bednarz says the newly renovated section has 3 new facilities, which include a bioengineering, nanotechnology, and 3D printing with new labs, creating a true state-of-the-art facility for current and future students.
Our goal is to get our students relevant jobs in their field when they graduate, so we want them to have their hands right in current technologies.
It's an $8 million investment in STEM education with a 23,000 square foot overhaul renovation. Randy and Robin Mark gave a leadership gift supporting the project. Randy has served on the university's board of trustees since 2013.
We have the opportunity to help inspire innovation and hopefully encourage success among the students.
Wilkes University's president, Patrick Leahy, says the country has seen a gap in engineering graduates, which he says has hurt the industry as a whole.
We as a nation need to educate more engineers in order to remain competitive worldwide.
The new renovations are a step in the right direction here in Luzerne County. In Wilkes-Barre, Cody Butler, Eyewitness News.
That project took 16 months to finish, and it was finalized in August. The construction was completed in many phases to avoid disrupting classes during the school year.
Okay, so definitely very proud of those new facilities we have. Okay, and next one I want to brag a little about Wilkes as a university. Here's from a journal, The Economist, and it was their first ever college rankings. So basically they took a look at students with their expected earnings versus median earnings after graduation and said, well, how well did the individual university improve their likelihood to succeed in life? And this is phenomenal that Wilkes was ranked 25 out of 1,200 colleges nationwide. And look who we beat out at number 26, MIT. You might have heard of them. So, this is the whole university in general, but I would suspect that most of this is coming from engineering. Not being egotistic, towards my program or, my departments in general, but I think really students are graduating, getting jobs in this area, $50,000-$60,000, and if anyone's from this area, that's a lot of money, for this area. It's definitely a lower cost of living, Northeast Pennsylvania. So in order, to be making that, especially right out of school, that's great, and makes it a lot easier to pay off the loan and to have a more comfortable living later on. So I did mention that we offer hands-on labs, and it does come from our smaller class size. We typically, for lectures, like to stick between 20 and 30 students for a lecture. It's just a big enough class that, again, I could learn everyone's name, call on them if need be. It's just a more easier environment to learn. For the labs, we try to stay even smaller than that, perhaps 8 to 12 students per lab. And that really allows the students to get hands-on with the mechanical design lab, the vibrations lab, the fluid mechanics lab. Here I'm showcasing the wind tunnel on the fluids lab. And I remember even as a student thinking, wow, this is the coolest thing in the world. I'm not just watching a TA from 20 feet away do the experiments. I get to actually push the buttons on the controllers, take my own data, and get experience on all these different pieces of equipment. So great experience for our students. And again, this is probably one of the hallmarks of our program. why I do say students are so prepared for the real world, that they not only get the experienced lecturers helping them learn the theory, but they actually get the experienced lecturers, and experimentalists helping them understand how these equations are applied in the real world. Students are given an opportunity to conduct research along with the faculty members. And for most schools, that's PhD level, master's level maybe. But here, we do have a master's program, as I mentioned previously, but also undergraduate students. We do encourage undergraduate students to get involved in faculty and conduct research. Typically they could do it for an independent study course and get course credit. I've had a couple publications with students, at the undergraduate level even, and conference presentations and so forth. So I think we are unique in that aspect, and I don't think many schools do that. That research with faculty can be conducted at the undergraduate level. Below, what you're seeing is a force transducer on a simulated Army bridge, kind of tying it back into my intro on my own research area and interests. That's simulating that big, large bridge crossing simulator that I showed from Aberdeen Test Center. Here's kind of a small scale. We had a tank that we drove over, and we're trying to measure the dynamic forces from the strain gauge electrical measurements. And there's just kind of a view of my lab during the end of senior projects. So you could see students working on a variety of senior projects and class projects for my advanced machine design lab. And then you kind of see the kids' toy on the bottom right. That's for an outreach event. So this was just kind of a fun picture I wanted to capture, that like the chaos, but also the collaboration going on. Another hallmark, I think, of our school is we offer a cooperative learning experience with local companies. So Northeast PA, if you're not familiar with this area, it's we don't have a huge company like Ford, or that's employing thousands of engineers, but there's a lot of local companies, and they all hire several engineers or several dozen engineers, and we have great partnerships with them where they specifically seek out, I need a Wilkes engineering student to fill this position. So we have great partnership here, and this offers students the opportunity to get hands-on real-world experience while they're still in school, and they could get it for course credit or not if they opt not to. So, but actually, regardless if they take it for credit or without credit, the majority of the internships are paid. So that's great. I know other majors, they may offer unpaid internships, just, you're getting experience, but no, students are getting paid maybe $15 an hour, to work or more to work as an engineer. Here's just some of the companies in our local area that we partner with, and all the students have been working with. I do recommend to all my students, actually, that they get some sort of experience while they're in school, either over the summer if they don't really want to interfere too much with their schoolwork during the semesters, definitely over the summer, or during the school year they can work 10 hours a week, 15-hour week at a company, something to put on their resume to differentiate them from other competitors when they graduate, to try to get them a job, because that is our number one goal. We want to prepare the next generation of engineers to get a job and be productive in the real world. I do want to highlight Sharon Castano. She's shown on the right with local radio celebrity Amanda from KRZ on the left. And Sharon's phenomenal. She's the director of internships and co-ops at Wilkes. And she works with all the different departments, but I think she especially likes to work with engineering students, and she really cares about our students and tries to help them with their resume, interview skills, applying for jobs, and what have you. Here's a great picture showing a collaboration with a local company. You can see myself in the Steelers jacket, along with 3 of my students. And so we partnered with Mountain Productions. They're a local company in Wilkes-Barre, and they set up floors for events. and then for graduations or concerts or what have you. So they have hundreds of panels that they need to ship to a site, set up for a week, and then bring back. And before they could ship it to a new site, they need to wash all these panels. And it seems like a simple activity. Oh, they just got to wash the panels. Well, they got to pressure wash every single panel, and there's hundreds of panels. It could take them weeks to wash the panels. So that's a lot of labor. It's a very labor intensive, dirty job. So they came to us, and it was a great collaboration that I had some students that were interested to work on this project, and they got credit for it through independent study course. So they got a great experience, something unique to put on their resume. We were partially funded through Ben Franklin Institute. Mr. Ken Okrepke's on the left. He really helped with the funding of this project. And then just great project overall. So the company paid for some of it, Ben Franklin paid for some of it, and Wilkes students got a credits for it. So it was a win-win partnership. Here's two of our former graduates, Adam and Andrew. Adam's on the left, Andrew's on the right, and they're working at Toyota in Michigan. And Adam was one of my students that I worked with closely. He worked on another independent study course with me, and he presented at a conference. And I just remember for years, he always had it as his dream. He's like, I want to work for one of the big car companies, and I want to work for Toyota. And sure enough, he got himself an interview, and now he's working out in Toyota. So he's definitely happy with where he ended up, and it's all mostly due to his motivation. I will say that, but I like to think that the experience he got at Wilkes as a Wilkes engineer really prepared him, that he could stand up for applicants. He was going up against applicants from the University of Michigan and University of Ohio, Ohio State, and he stood tall. They said, "Wow, you have really great experience as an undergrad at Wilkes that we're not seeing at these other schools," and they hired him. So now I'm going to make it a little fun. I'm going to showcase some of the community outreach we do. We like to get involved and showcase science and engineering to local fifth graders and, seventh graders, ninth graders, all, pretty much middle school, early high school. Adventures in Science, Women Empowered by Science, Webs. And it's a nice way we could give back to our community. Our students like to get involved and help the kids play with different engineering style toys, and just kind of introduce what is engineering to students. One of the difficulties we have marketing engineering as a profession nationwide is a lot of people don't know what an engineer is, and what it is as a career. You don't go to the engineer, you go to the dentist, you go to the doctor, right? You may have to call a plumber, but you don't really know what the engineer is. The engineer is the one behind the scenes designing all those cool things you use in your house. On the bottom left, it was a demonstration of a Rube Goldberg machine. It's kind of a fun engineering tool I like to use. I make it a design project for my advanced machine design class, and in this case, it was a great demonstration for kids. If you've never heard of a Rube Goldberg machine, pause the video, go to YouTube, and just look up Rube Goldberg machines. They're awesome. There's a really cool one I just saw recently. It was like a guy making a basketball shot. He was outdoors and he started this elaborate contraption, and then at the end it made a basketball. It was like a 2.5-minute video. It's basically a overly excessive and elaborate way to do a very simple task. But it's a great demonstration of energy transfer and various mechanical systems and electrical systems at work. This was part of my freshman class that I talked about. We had an egg drop competition where they had to utilize different materials, and kind of a way to get freshmen involved in what is engineering design, even though, hey, you may not have the math, you may not have all the tools that um, engineers who have graduated have, but you still can take different objects under constraints to purpose them for a specific task, and you have that ability even before college. And I like to let my son try to design things as a middle schooler. Now he's a high schooler, actually. So here is the adjustable wheelchair. So now I'm gonna highlight several senior projects, but this one I talked about a little earlier, so I'm just gonna briefly. Here's what it looks like, and there's the contraption. And basically, once it adjusts to a specific width, it'll fold and then come right back to that width. So if someone has it adjusted to their liking, they could fold it, transport it in the trunk of a car, and then it folds right back. They don't have to worry about that. And that's kind of one of the features that makes our patent unique. And that was mainly our main claim. Because there are other similar type of adjustable wheelchairs on the market, but we're the only ones that go back to where it started from. So this was designed using CAD and then the physically built prototype. And it was a great collaboration. Heather, she's a licensed occupational therapist, and she came up with a lot of the core ideas, but then the students came up with the different gear mechanisms and screw mechanisms, and they actually built it. And I tried to input where I can as well, and we all kind of guided the project along. It was great. Another senior project, and I'm kind of I've been involved in probably 100 senior projects since I've been as a faculty member, so I can't highlight every single one, but I'm trying to just highlight the diverse nature of senior projects. The wheelchair was something, piece of equipment that was small, tangible, easy to grasp. This next project was students were advisor to, so I was an advisor to a senior projects team that was converting an old church into a parish center. So the team received a lot of real life experience working with the customer, and they were able to repurpose pews into creative furniture designs, and they actually got hands-on with the build. They modeled this all up. This is in a picture up here. This is a computer model showing all the different partitions that they were going to design to make this a functional parish center. They did acoustic analysis. If anyone's been in a church, you know that churches are designed to carry sound. Well, for something where you want partitioned rooms, you don't want it to carry sound. So they were able to do a lot of acoustic analysis on it. So electrical work, it was great project overall. And then we wanted to do some testing on the pew. So there's myself in the green, Eddie again, he seems to be in a lot of these videos, and 3 of our students. And we put strain gauges on the pew, and we just wanted to do some dynamic testing where if someone sat on it and started bouncing, would the wood break?
1, 2, 3, go.
So that was a lot of fun. We got to do some real world testing. And this is my absolute favorite part of senior projects is watching the students that most of them probably came in as scared freshmen, and I say, hey, you got to do a presentation today. And they say, what? I don't want to do that. But then watching them as they're seniors stand up there, dressed nicely, confidently present, this is our product and this is how it works. And in Stark 101, which is the largest classroom we have at Wilkes. And it's just great watching them grow from young adults into adults. I'll put it that way, from freshmen to seniors. Here's a couple other senior projects I've been involved in. Punkin' Chunkin', that was a great one on the left. High lift dump trailer on the right. So that was a way to dump maybe mulch into someone's yard with a fence, right? So a great practical real world problem. Our students are given a budget of $500 as a team, and they could. So it's a real world constraint. You have this much money to spend to design and build your product. Now the one on the right, it's going to cost several $1,000s. We knew that right off the bat. So they actually partnered with a local company that was willing to donate materials and labor to help them with all the massive welding, machining operations that were needed. And our students loved getting hands-on too. You know, they spent days at the company helping them with, you know, create the final product. But then the company would get the trailer at the end. So that was kind of the trade-off. So that was a fun project. There's the pressure redistribution system on the left, and that was my 5th patent that I previously talked about with Heather. And you could see all the electronics involved. And there's a load cell under the seat that basically sensors which section the person was sitting on, and would they, and to make it move. So there's like an air bladder with a pump. The one on the right is a liquid resin 3D printer. So that was a fun one. I had a group of students, motivated students, and a lot of these projects, they come to me and say, oh, I got this idea. So sometimes I have an idea that I'll pitch to the teams, or in the case, you know, Heather was the one with the 2 wheelchair ideas. But then the one on the right, the student said, I want to build a 3D printer. I said, okay, that sounds like fun. I'll do the best I can to help you. So there's many different types of 3D printers. The one I showed you before was a fused deposition modeling FDM printer. This one's a liquid resin 3D printer, where it basically uses a UV light, which we have a projector there, that flashes an image into the resin and cures a layer at a time, and then it lifts up, and then it cures the next layer, and it continually flashes the image. So you can see how this one would go a lot faster than the previous one that would just draw a little line at a time. And they actually did get it to work, and I have some of their 3D printings that I usually pass around for a demo. This was another fun one, and this was a student-led one. They said, hey, you know, when we go to a bar, the bartender needs to mix drinks by hand. What if we made an automated drink mixer? I said, that sounds like a cool idea. So they basically made up a system where they would program in different drinks with different amounts of liquid, and they would just push a button, and there would be a whole series of pumps that would mix a drink. So they could say Long Island iced tea, and it would go psh, 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 and it would shoot it in. So for the final demonstration, what you're seeing there in Stark is not alcoholic. They were just colored food colors, but they wanted to demonstrate it in the building. And I said, no, you cannot bring alcohol in Stark. And then this next one was Rube Goldberg, which I talked about earlier. So this was a great project to be involved in. They got to design their own Rube Goldberg machine, a really large-scale one. And they won the Online People's Choice Award in 2017. So that was fun. We wanted to go to the national competition, Rube Goldberg competition in Indiana. And we actually had it all set up. But then the Pi Day blizzard hit at 3/14/17, and we got pi feet of snow, at least at my house, and we cannot go. But they were able to record their video and send it in online, and then they got the most votes online. So that was fun. And here's another project that I want to showcase. It's called Unplugged, and they wanted to turn gravitational potential energy into electrical energy for the purpose of charging a cell phone. So that was a great project. You know, I was so happy to be involved in that one. It was basically, if you're out in the woods and you're stranded and your cell phone dies and you don't have an emergency charger, this is a way to create your own energy to at least juice up your phone enough to make an emergency call. I'm going to pause it here.